So today's discussion series is the first of our series for the Studio for High Performance Design and Construction. And for those of you who are not familiar with the studio, or the SHPDC as we like to call it, we are a nonprofit organization that's based in Newton, Massachusetts. And there are two other folks on the call today. Aaron Gunderson and Nick Falkoff are the other two board members, and Aaron's our executive director. And so we've been doing programs in Newton for the last few years, basically starting in around 2018. This is the studio classroom space in Newton, where we've held a variety of workshops, passive house trainings, events for homeowners. We often are hosts of a monthly Building Science for Carpenters discussion group. And we put all of our programs on pause, basically, for the past year or so. And this spring, we kind of got back together and said, we still can't quite meet in person, but we'd love to be able to do some programming. And so we put it out there that we're going to start this monthly building science discussion group, and figured we'd see who we got and pick some topics that it seemed like were of interest. And it's great. We had 30 or 40 folks register for today. So we're excited to see so many faces and from all over, and really being able to kind of expand our reach beyond just the local Boston area. So, stay tuned for our additional series. The next one in April is going to be on indoor air quality, and Nick's going to be facilitating that one. And we'll be continuing to post other topics as we go. And so today, our plan here is to have a relatively informal discussion. We are not going to do, a whole bunch of slides. Like, the idea was really to get people talking to each other. But we do have some discussion questions, and our main housekeeping things are, we just ask that you stay on mute until you're speaking. And since we do have a fairly large group, if you can use the raise your hand feature. So on the bottom of the Zoom screen, there's like a little thing where you can, either in the participants window or in the reactions, you can kind of raise your hand, or you can literally raise your hand if you want to. But that'll help me kind of keep a stack of who's wanting to speak. And I've prepared a list of kind of some general questions that I have about wood stoves and high performance homes. And I'm sure you have lots of other questions too. We're all here to learn, and there's not one expert in the room. So part of this idea was really to learn from each other, what folks have been doing, what's been working, what some of the challenges are, and share the best practices, share what we can, so that we can all do this better. So I'm going to stop sharing the screen here so that I can, let's just run through these questions, and then I'm not gonna leave them up the whole time, but I'll put them in the chat so if people want to reference back. And then we have a few folks in the room who I know have some experience in this department, and so we're gonna kind of start the discussion by tagging some of them. But really, we want to talk about kind of what are just the general challenges when we try and put combustion appliances in a tight, high-performance home. How are we dealing with dedicated air supply? Are there particular manufacturers, particular stoves that have been working well for folks? Anyone have luck convincing their clients to not to choose an alternative to combustion appliances? And then how do you manage the sizing? Are we talking about wood stoves as primary heating, or more of a backup resilience strategy? How do we deal with indoor air quality and particulates and all of that? So those are some of the topics I'm hoping we're going to get to touch on today. And with that, I'm going to stop the share so I can see everybody better. And let's see. So I want to kick it off, and yes, but I'm going to put you on the spot because I know you just retrofit your house. to the Passive House standard, and I'm curious what the considerations were in that process with your wood stove.
Um, well, I mean, I guess the main reason I did it is just because I live out in the woods of Maine and I have tons of wood on my property and we frequently lose power. So it just seems an easy way to have a way of heating your house when you don't have power. And obviously, um, so sizing it based on what the heat load is in the house, finding a small wood stove that fits in that space. And I think the biggest concern is probably indoor air quality, making sure that the ventilation system isn't sucking smoke out of the wood stove and killing everybody at night while we're sleeping. Um, so, getting a dedicated air supply into the wood stove. The wood stove works beautifully. I haven't had any issues. The only issue I've had in terms of smoke in the house is when you know, if it's kind of smoldering and you open it before it really kind of flares up and you might have the door cracked, um, I mean, I will say I also we did hit like 0.45 air change an hour and the retro of 4.5 air change at 50 Pascal. So, I mean, the house is tight, but at the same time, I'll also say I've also shoved a t-shirt into my dedicated air supply and the wood stove didn't seem to care. So I wouldn't say that you shouldn't have the dedicated air supply, but I was really surprised. So um, that's kind of like the quick and dirty. But I mean, I think I will just say that um, that's obviously, the air quality in the house every time you open the stove. I think you're getting like 3 times as many particle pollutants in your house, according to this UK government study that I just read. And I also found out that according to this UK study that I don't know if anybody else has read it, but I'd be happy to share it. But 8% of the population in the UK use wood stoves, and yet the wood stove particle pollution is responsible for 3 times as much pollution as cars. So I don't know. Like after I read that, I was like, all right, well, my wood stove is for backup, and it's not like I'm not going to try and use the wood stove to heat my house year round because it's cheap. So I guess with that, I'll shut up.
Thanks. I also remembered, I'm curious where everyone is coming in from. So if you have a chance to, throw in the chat, just like, where you're from. One of the, knowing some of you, I know we have quite a nice spread, some Canadians and folks from different parts of the United States. So I'd be curious if you want to share just kind of what climate zone you're coming in from. And we're just interested too in who's here. So let's see who, in terms of our next questions. Jacob, I know one of your questions was around kind of the sizing and how do you control the wood stoves, and I don't know if you want to speak to your experience with that and from the mechanical side of things.
Yeah, sure. It's tricky. I think the thing that we found to be really interesting around trying to get good, accurate sizing is that it's so heavily dependent on use and fuel quality. So there are these like really significant variables that are pretty much outside of the designer's like direct control. How is that thing choked down? How wet is the wood? What's the species? How big are the pieces? All of those have some pretty significant impacts on both the output and then also on the control as well. So, where we've seen it work pretty well to have a wood stove is when it's not being asked to do a small job and when there's a pretty decent amount of you know, runway, kind of on the other, after you've damped it down, that, you know, well, let me say it this way, maybe the easier way to describe it is where we've seen trouble is when someone's trying to use their wood stove in, like, you know, shoulder seasons or like real part load conditions, or when they've using a wood stove in a low load building that also has a really high amount of solar gain, or has some other high mass system that is also like a co, you know, is also running in some part over a 24-hour cycle. And those conditions make it a lot more challenging to keep a you know, a controllable temperature in the building. And then invariably what happens is you choke the wood stove down, and now you've like dramatically increased your inefficiency and your you know, combustion pollutants and all that jazz. And so you know, for the low load houses, I mean, and to be totally clear, there's my wood stove, sole heat source in my house. So I say this as someone with I wouldn't say a super low load house, but pretty darn low. And yeah, it's a real pain in the ass this time of year. We actually have a little like propane backup that gives us electricity. We're off grid for the first chapter of this building's life. And so, and we live up in, I didn't get a chance to enter the chat. I'm up in the mountains of northern Vermont on the Canadian border. Cut out my own wood for a very long time. And it was that sort of resiliency and fuel autonomy motivations for me initially. And as you know, it's, yeah, it's it can be tricky. I've had to split wood down a whole lot more than I've thought that I would. And that's definitely, when we've had wood stoves go into folks' houses, it's very much a matter of getting a small unit, and really, like, more than anything else, it's become a long conversation around setting expectations and firewood management. A lot of those small stoves, the ones that are actually pretty well sized, especially for a smaller tight house, only take like 12-inch wood. And it's one thing to split bigger wood down into smaller pieces. It's another thing to have to cut an 18-inch piece down to 12. Like, that's, no one's going to do that. Or if they're going to do that, they're like really committed to a lifestyle. So it's those type of like edge conditions tend to, like, you know, move past the point of practicality. And so when we're talking with folks that really want a wood stove and want it as a primary heating source, that's where it really becomes a lot of conversation on lifestyle and fuel wood management to manage getting a decent combustion off a really small load, and being able to control that it's not going to overheat with two other heat sources from both the sun and the other heating system in the building, helping throw off what you can manage.
Mm-hmm. Great. So as questions are coming up, feel free to either put them in the chat or raise your hand if you have particular thoughts, things that you want to talk about. Jeff?
Hi, Kate, and you folks I know. Just wanted to throw in there that we've had some experience over the years more with like remote systems. So, you know, like at Cobb Hill Co-Housing, there's one boiler that's in a remote building that heats all 22 homes. In the Knoll Farm, we did a TARM system that has remote storage. So there is a, you know, one way to do it is in bigger complexes and groups of homes, is to do something where, you know, if it's just for heat and it's not because you like to look at a fire and you like burning fires in your kitchen or whatever, you know, there are ways to do these things where they're just, and control them for small loads, where you're storing it in tanks, storing, you know, hot water in tanks, and, you know, it's not so much a wood stove. So I guess it's a little bit off subject if this is really just about wood stoves, but I would just sort of round it out in that direction. And I'd just say our one experience in a super tight house with a tiny wood stove has been good, but it's hardly ever used. It's like at Meta Earth, we did the Elder House, which with Chuck Reese, and it was I don't know the model, I could find out and dig that up for you, but it's a tiny, tiny wood stove. It's a tiny load building, and they only use it if it's like below 20 below out or something like that. So it just doesn't get used unless it's a heat pump house, it's on grid, super low load, net zero home. But, you know, it's nice for them on those super cold nights when either the we did it in the kind of, for us, the earlier days of using heat pumps. So we weren't fully convinced that on the coldest nights it would be able to carry, and it was for an older couple. So we wanted to make sure the house could stay warm. But I haven't heard any problems with it. It works fine. Because they use it so little, it doesn't have the air quality problems. So if you're interested, I could dig in on. I know it had a dedicated outdoor air direct into the stove. Chuck sourced it pretty carefully.
Mhm.
I would say, actually, while I'm on, just for a second, that I helped facilitate the conversation at Cobb Hill over a 2-year period where the group of people were trying to figure out what they wanted. And the biggest conversations that went on for the longest were about whether people could have cats because they love birds, and whether people could have wood stoves and fireplaces in their individual homes. And that conversation came to be titled Fire Desire. And what they actually really did was kind of interesting in the end. And this was like a long facilitated thing with a lot of really interesting people. And Amory Lovin's kicking in with Mark Rosenbaum and back and forth. And they wound up building a fireplace in the common house so that people who wanted to sit in front of a fire could go there. And I've seen people do it where they do like an outdoor fireplace. So that's like, you can go kind of get your fire satisfaction there and just kind of get that stuff out of the house. So sitting here in front of my fireplace,
Right.
which has like a top damper and glass doors and is pretty tight, but is something I really love. So
Mhm. Thanks, Jeff. So Sarah, or the rocket crew over there. Is it Will?
Yeah, I just wanted to just add to that like the experience that we're having mostly with our clients has nothing to do. Well, there's a whole sort of power failure aspect, resilience aspect, which out in the country I think is real, and I think like Jessica was saying, it's like it happens, but it's a conversation that lasts a long time because they just want a wood stove. And it has very little to do with the performance or energy or heat or as your primary secondary source. And we end up having a conversation that is sort of along the lines of, do you like to watch television or not? And so do you want to have a TV room or not? And for a lot of people, it's just they just want a wood stove, and and needing to explain to them that you're going to have to crack a window, which has sort of a double benefit of letting some of the heat out, which just happens when the house is small and tight and the stove is running, but also can bring in like a bunch of fresh air. So I don't sound like we're encouraging them. We just tell them that you don't need this in your house, but they just want one, right? They're out in the country and they're in the middle of the woods and they have a bunch of firewood that they've just cut, 18 cords of firewood that they've cut down to make space for their house. And then you tell them that they can't have a wood stove. It's like, you're sort of crushing their dream, right? So I think that like part of the wood stove conversation is, I think it's interesting to bring the pollution aspect to the table because it's a really, really important one. But more than comfort, we're talking about just like lifestyle, right? It's, people who like having Wi-Fi instead of wired internet. It's like Wi-Fi is bad for you, wired isn't. I don't care, I want Wi-Fi anyways, right? So it's not just about energy, So that's just our experience.
Anybody else have a specific question? I'm curious, can we talk a little bit about the dedicated air supply, how that works, and who's been able to do that successfully? How did you do it? Jesper?
I literally just came from the hardware store, so I just couldn't resist. So what we typically do is we'll get this flexible ductwork, and then we make sure that we set it up so it is directly outside from the wood stove. So, we try to set the wood stove, set it right up against the exterior wall, pop the flexible ductwork through the wall, connect that to the wood stove, and then on the outside, get like a nice dry vent or something, and then just pop the little rivets on the side here off, and then take the flap out. So it's always open. There's a little grate in here that keeps, you can't really see that, but it's a little, you can't see it, but there's a grate in here so birds and critters can't climb through it. And then we just connect that and possibly seal it up with some kind of high temperature caulking. So pretty simple. And I know, I guess the fear is always that, like somehow stuff gets reversed and all of a sudden the smoke and flames are coming out through the, through the air supply. But I don't know. I guess personally, I have a hard time seeing that happen when heat is rising, and it's gonna want to go out through the top of the stove. But that's how we're doing it. So I think the key is just to have it on the outside wall. You obviously don't want to run this dedicated air supply that's uninsulated through your house for, for several feet or whatever. So.
Mhm.
I can definitely speak to the not running an uninsulated duct coupled to the outside many feet through your house without it being sealed and insulated and protected from condensation risk, particularly, and then also just comfort depending on how close to a floor that may be running. I've seen various versions of the design where there's either a slide gate damper or a butterfly damper kind of at the wall, which I don't know nearly enough about the pressures relative to the spring load on the butterfly damper, but I would expect that that's not going to be enough, and that it's like when it's just trying to get a draft is when you really want that air, and that a butterfly damper wouldn't do the job. So I'm not a big fan of seeing that detail, even though it does keep it closed when the stove's not running. And then the problem with the slide gate damper is you have to actually remember to go down and open the slide gate damper before you turn on the wood stove. And I really just don't trust the fourth owner to remember to do that. And then it makes the entire thing kind of a, well, you've now lost all the efficacy of your air supply if it's damped off at the wall. So for me, I've sort of accepted it's gonna be open, and that's kind of the price of, admission if you're gonna have a wood stove. And I've heard the countervailing argument that, well, it's a manually operated thing anyways, so it's not that big of an ask to manually open up that slide damper. And if it's an operable control within reach of the wood stove, and you're that close, you've got the architecture dialed so that it's that close to the exterior wall while still having your chimney decoupled from the thermal enclosure, which is a bit of a needle to thread. But if you've got that going, then like all for it. Otherwise, I think that's just another part of the inefficiency of the system, which for me, I would err always on the side of health and safety over efficiency. Although to Jesper's point, I've also definitely had clients that have had a slide gate, one in particular where they insisted on putting something because they're using it intermittently. And so we came back and put it in, and then they left it closed for like the whole year. They forgot that it was installed. And for the most part, it was working fine, the wood stove. So yeah, I wouldn't be the one to, speak with any authority on their like absolute, requirement or necessity. But I would, those can, some of them I see those like control pieces makes me a little nervous.
Mhm. So Dylan, I'm going to put you on the spot because I feel like you started some of this conversation a few months ago with your conversations with your clients, and they were wanting a wood stove and you were trying to convince them not to. And do you want to talk about sort of the questions that came up in that conversation?
Yeah. This always happens, right? You're going to build this great, nice, airtight house, and they want to put a stove in. And so I still haven't won this battle. The project we're working on now is going to have some sort of a wood stove. in it. And in this particular building, it'll work as auxiliary heat. So there's that benefit. But, you know, we have a high output range hood. And I think Jacob helped me with some emails on that topic. So we're going to have a Electro Industries or some variation of the Makeup Air program to make that work. It just kind of keeps happening, you know. It's like the same curveball, like, oh no, another stove, and you try, and it's such a it's right. I forget who was talking earlier that said about, you know, kind of crushing somebody's dream. They these folks are from the UK, and the husband is really used to burning firewood in their home in Scotland, and so this, me trying to engineer this out is like, it's not going to happen. There's just I'm not going to get this one, and that's okay. We just have to make it work somehow. But there's a lot of competing pieces of equipment in this house. There's a powerful range hood. There's a what else do we have? Well, you know, no one's brought this up, but I was wondering about this. What about central vac? I mean, that's a powerful exhaust only appliance that just got vetoed from our project, so I won't have to worry about that one. But yeah, what else can I say? It keeps popping up. I've done 2, and I've had problems with, you know, 2 houses with wood stoves, and both of them have issues. And it's usually the not balanced ventilation that's just not compatible in any way, shape, or form, as far as I can see. But even with balanced ventilation, a little wimpy 250 CFM Braun range hood will fight a Pacific Energy stove, even with its own combustion air, and they just don't play well together, you know. And even when you're so sure you did everything right, it has proven to be a challenge.
Mhm. Ken had a question in the chat, which was, has anybody used a draft inducer fan? Nobody? Okay.
I was under the impression that that's a no-no with solid fuel, particularly because of sparks and embers. I don't know if that's the case, but that's always what I've had in the back of my head. If there's someone that actually knows more about why not, I would love to hear. That's always the impression I've heard around solid fuel and powered assist.
Yeah, Ken, do you want to chime in there?
Yeah, sure. So we certainly can't use the draft inducers that we would throw on an atmospheric boiler. These would have to be, and I'm aware of one company that makes them, but specialized solid fuel specific draft inducers, and they're not cheap. So I'm just curious if anybody has run into a situation where a client would actually go for that.
Brad, did you want to?
Yeah, I've installed those on fireplaces, and they're typically 2 or more stories up the chimney, obviously, from where the fireplace is located. And it's a stainless steel, and it usually includes, it'll close. It'll be a closing damper and then a fan built in. So when the fan's on, the damper's open. And we've used that to actually maintain draft even when they're not having a fire, because they'll get backdraft from all the other ventilation exhausting in the house. And specifically in one house, we were seeing the ash spreading in the living room, a very faint, you know, sort of ash or creosote layer that would build up over a couple weeks on the hardwood floor. So leave the draft on.
I'm assuming that's not as much of a high performance house that you're talking about.
That's a large single family residence in Cambridge, Mass, that had been renovated at various stages and had, I would say, high performance rooms, but not a high performance overall shell.
Mm-hmm.
Yeah.
Yeah. Great. Let's see, Frank. Frank, do you want to unmute and ask your question?
Is that better? Okay, I'm one of those darn clients that insisted upon a wood stove. Nick Falkoff built our house. It's a passive house in Wayland, Massachusetts. So you know it has to be a lousy house to begin with. Sorry, Nick. We put the stove in originally for two reasons. One, but for lifestyle purposes, and the second, Wayland does have a lot of power outages, so we thought it would be a good heat supply. We've not needed it for that. There are a lot of power outages, but they're usually short-lived, and we've had typically one fire a year. We do have a dedicated air supply. Everything works beautifully. It has not been a problem.
Although, Frank, we did have the birds that got in when the vent blew off. That wasn't unusual. That was unforeseen.
Well, yes, that was unforeseen, but it wasn't that the vent blew off. It was that there was no grate at all up top. And the birds got all the way down and came into the house and
Had to come out through the fireplace.
yes, but we took care of that.
Great. One of my other questions, and I see Karen, you're here from the EIC. I'm wondering if you might be able to speak to at all the challenges of passive house certification when using a wood stove. Is it possible? Can we do it?
Yeah, it's definitely possible. I just finished testing a home that has a wood stove that is in the process of achieving its passive house certification right now. Yeah, that's where I see most of these projects. I kind of regret that I don't get to hear these stories of how the stoves are working after the fact, because we're just there for the final inspection and then say goodbye. But yeah, the air tightness test is obviously a big piece of it, and that really can the choice of stove can affect that a lot. A lot of the stoves that you guys are talking about are doing really well. I mean, they just need to have a really tight gasket, a tight fitting latch and a good gasket. And we are seeing almost no leakage out of these that is visible or measurable. So that's good news. But I also test a lot of homes that are not going for passive house certification. And I test homes that have fireplaces. And Efficiency Vermont has a requirement that you have to have like a gasketed door, and a lot of the fireplace type stoves that I'm testing have like a guillotine style heat resistant like glass door, and those are so leaky. And these homes are going for, usually they're trying to achieve something close to passive house level of air tightness, and a door like that is just a huge it's a huge issue with trying to achieve that. I try to always talk people out of it, but like you're all saying, they really want their fireplace. So yeah, on wood stoves, but no on fireplaces.
Okay. Thanks. Let's see, I'm going to go to Sarah and then Jacob next.
So I did a little blower door test on a house for some guy who just called and asked us to do a little smoke test for diagnostics, and it was like 0.5, what was it, 0.57 or something like that. And he had a wood stove, and I guess the dedicated makeup air, and a lot of the ones that we get here have these, little pull that goes into the exterior wall that opens the gasket. It wasn't the damper. It wasn't our house, but I mean, we didn't build it. But it was interesting when we did the smoke test, some of the doors and windows needed tiny bits of adjustment, but the bulk of the smoke was coming out the chimney. And it was from, I don't know if it was the stack or the actual stove, but it looked like there was a fire in the stove because all the air was going up through anyways, it was just interesting. Would have been interesting to see what the results would have been without the stove.
Jacob?
I did just want to name, I feel like we've been talking a fair amount about helping our wood stoves to function in the light of, or in the environment of various pressure imbalances. And can we just talk about like really trying to never put a 600 to 1000 CFM range hood into a building that we know is going to have a regular operating wood stove, and just like talk about that for a second? Because oh my gosh, having had to, I will attest in a recent project of like sort of losing control of the decision-making pipeline when the owners picked out their own kitchen appliance. And despite having noted things and written things down and talked about in meetings and prior conversations, somehow a 600 CFM range hood managed to find its way in well past the point of no return, which then triggered like Herculean acts of mechanical, what I consider weakness to try and compensate for the conditions in which that might happen. And I feel like pretty good about the amount of what we did to make sure that the wood stoves won't immediately start running the wrong way once they burn their eggs. But God, just like not having to be in that position in the first place ever. And it is like, I find myself having more conversations with folks about having a range hood that is the width of the stove and the depth of the stove and at the correct height. And like that conversation like dominates more kitchen design like conversations than maybe anything else we talk about, except tile selection. For some reason, it always ends up being a drama. And it's like just so fundamental to this entire conversation, which is not to say there aren't other reasons to talk about that, but there's so few other like 6 to 1000 CFM fans running in like normal residential buildings. Not that there aren't other potential culprits or accumulations of other fans depending on the circumstances, but the like wood stove range hood like relationship is like it's just such a thing. And I would hate if we went this whole hour without calling out that big exhaust elephant in the room.
Right. Nick, did you want to chime in there?
Yeah, I think that would be a great follow-up session to do just like on ventilation and high performance homes. I feel like we could do a whole series on just like makeup air in these homes. And like the more we dig into it, like we learned a lot from working with Mark Rosenbaum on Frank's house. But like when we go to do this makeup air systems, like none of the manufacturers know, but not to go off track, but it'd be great to do a whole nother session just on what do we look at with makeup air sessions? What are the impacts? And like, I think it'd be like, there's a lot of bad practices out there, and the more, so just as a future topic.
Great. Mark, do you have any thoughts? Things that we haven't touched on yet that you think about when you're looking at projects with wood stoves?
I think I've lived 3 years in the last 45 without a wood stove. And many of the earlier years, it was the only heat. So I have a bunch of notes from the talk, and I'm glad that some of you are discovering the same things that we learned, 35 years ago. It's good every generation, gets to do it again. So first of all, how many people have any idea how many CFM a wood stove actually uses when it's just burning? Not a fireplace, totally different thing. Wood stove, field combustion wood stove. It's only 10 CFM. And you can kind of do the stoichiometric calculations. It's a very small amount of air. I mean, maybe a big stove is bigger, but none of us are talking about big stoves. So in the context of the flows that we're talking about, it's really small. And I have never encountered a building that would not sustain combustion in a wood stove that was too tight to sustain combustion in a wood stove without any kind of outdoor air supply. I'm sure that you've all built houses tighter than mine, but my house is 140 CFM 50, and the stove is fine. It doesn't take hardly any range hood operation to backdraft it in a house like that, right? And you can calculate that, so it's pretty easy to get a house to 25 pascals negative with a really cheap, Broan, crappy, bottom of the line range hood. I think there's a fork in the road. Certainly there's been a big change over years in my practice. Originally, I lived up north. I was working with people who were going to use the stove for heat. And we never did makeup air systems. We understood that even a small range hood would backdraft the stoves, but those people were living with it as part of their life. And they didn't have to, it was something that was easy to communicate. So, you know, I never did a makeup air system until I started to work in houses for bigger houses for wealthier people, which interestingly enough are less likely to get depressurized because they're so much bigger. You know, we're not talking about an 800 square foot house in the woods. But you're going to have people that are operating that just have no idea what they're doing. And they're going to have friends come over, or they're going to rent the house for, you know, now I live on Martha's Vineyard, they're going to rent the house for a week. And what happens then? There's no protocol. You're not going to teach the new person. So I think you need a makeup air system. Like, I don't have a makeup air system. I bet Jesper doesn't have a makeup air system, and I bet Jacob doesn't have a makeup air system. And, you know, we all have learned, and I bet a bunch of other folks here have learned, that the first time you turn the range hood on and the building starts to smoke, because it happens like this, it's like, oh yeah, I'm not going to do that again, right? So there's, you know, there's a very, very steep, quick learning curve. A couple other things. Metal Bestis type chimneys are way better. They warm up quickly. They have very little mass. You don't have the backdrafting issues nearly as much. I don't even think they're a problem on the outside of the building. So we all know that you don't want to put a masonry chimney on the outside of a building because it takes forever to warm up. But what I ended up doing in my current house is the wood stove is a modern Scandinavian stove, double wall, which is great for little houses because you can put them really close to combustibles, right? I think my stove is 150 millimeters from combustibles is the spec. The exhaust goes right off the back. It's about, you know, 6 inches from the wall. There's a slide damper on that. So it's not only, there's no intake air, and there's a slide damper on that. And the whole installation, because it was the last thing I did sort of in the house, the stove, the penetration for the chimney, everything added 5 CFM50 to the house. So I think you can do this well. And one of the advantages in an intermittently used stove where it's not really the heat is that if you are going out through the wall, oftentimes you're much closer to the neutral pressure plane than if you go up through the peak of the roof. So in the times when the stove isn't being used, it's not seeing the natural pressures on the house are quite a bit smaller. And I think that it's contributing much less when it's not being fired, even without a damper, if it isn't going straight up. The sizing question is a great question that I think we've been wrestling with for decades. And I think the solution, someone said it, dry firewood, small fire, right? So every fire isn't the same size. And you know, we certainly had a lot of shoulder season time when the stove was the only heat, and the secret is small fire, and it's going to burn out. And so my neighbor in Meriden started 1 fire a year in the 200-year-old farmhouse. That was started sometime in September, and it kept getting fed until May, right? 1 fire, 1 lighting of the fire. You know, this much kindling a year. I figured that my house in Meriden, I started something like 75 to 100 fires a year, right? Because it's also a solar driven house. So, right, there's going to be whole stretches of weather, even if it's cold, with the kind of houses that everybody here is building and knows about, where you don't need a fire. So you're going to start a lot of fires. And people have to learn how to do that without putting a lot of particulates in the air, because that's actually when you have the most chance of a lot of particulates and backdrafting, right? I mean, it's just, so everything's got to be dry. I'm very skeptical of makeup airs directly to the stove in terms of that solving the problem of not backdrafting stuff into the house. And the reason for that is. And by the way, you can tell I have a lot of opinions. Many of them are wrong, so don't feel, bashful to argue with me, particularly if you have some evidence. But anyone who's lived with a wood stove for a long period of time and really is using it for heat knows that unlike a gas furnace or boiler, which is sealed combustion, you actually have to put the fuel in the device on a periodic basis. And so that means you have something called a door, and that means the door has a gasket. And so you could hard pipe the exhaust and the fresh air to the stove, and it could be welded. And the weak point is the door. And it doesn't take very much pressure below outside pressure to pull stuff back in through any crack. And the place where I've seen that the most dramatically is in a big house, but a tight house with a Clevis Multrum. So the Clevis is a constant exhaust fan, but it's a teeny exhaust fan compared to what mostly we're talking about. And there's a fireplace with direct outdoor air to the firebox and good glass doors. And that house smelled like creosote all the time. And it had a balanced HRV system. And after about 10 years, we pulled that out for them. And because their complaint was draft. Their complaint was, well, when we use the fireplace, the draft isn't good. But every time I walked in that house, it just reeked to me of creosote. And so we took the HRV out. We used that supply ductwork to bring fresh air in with a makeup air. This is now a little makeup air system, right? Because it's offsetting the 75 CFM of a Clevis with electric heat, modulating electric heater, because we're bringing that air to the bedrooms and the public space for ventilation. It's still ventilation, but it's not balanced ventilation because it's going out the Clevis. And then we used a variable speed ECM motor fan, a Fantech, and we set it up with a switch. So when the switch is off, it just runs to balance the Clevis. And it's very slightly pressurizing the house so that they don't backdraft through the fireplace. And when they're going to start a fire, they flip it up and you get another 4 or 5, I think we picked 4 or 5 pascals of positive pressure to get the fireplace going, and then if they want to turn it down once the fire's going, that's fine. If they want to flip that thing back, it's not a lot of air because it's a tight house, right? So, if you had a 5,000 square foot house that just met code air tightness, you're moving a lot more air. So all of these things become easier as well as harder in a super tight house because the air streams you have to move are so much smaller. Central vacuums, a lot of central vacuums are available where they're not venting outside. They're filtered and so it's not an exhaust fan. Most of them these days are actually not exhaust fans. ERVs are interesting because my long-term experience, and again, other people's may be different, is that the fresh air filter is the one that plugs the fastest and the most significantly. And it's typically pollen. It depends where the inlet is. If it's really close to the ground, it's going to plug from just ground detritus. But mine's up in the air, and still the fresh air filter plugs more quickly. And so what that does is it biases the house towards more exhaust than fresh air. And the house kind of slowly goes slightly negative. And I don't think that's a big problem in terms of the wood stove, but it's a reason to change filters, when you have any kind of combustion in a house is to pay attention to what the house pressure balance is. That also is related to radon. So there's other things that we care about that are negative. And I guess the last thing that I have on my list is responding to Jacob and the exhaust elephant in the room. So I think everybody here on the call who's practicing professionally knows that the people making the giant range hoods and selling them have totally blown off the problem. I mean, if you try to get anything out of Wolf, for instance, at my most recent encounter, the most they're going to do is sell you a motor damper, which is either going to fail open or close. You pick which one, you know, it's a coin toss, but it's going to fail and no one's going to ever know about it. So that's not a solution. And one of the things that you'd really like in a makeup air system is you'd like it to track a variable speed range hood fan. If that's what you've got, that's what you'd like. And the best system that I've found is Famtech, because you can buy a control that will, and you can buy the same fan for the exhaust and the supply. So you can get ECM motor fans, and then you still have to balance them, but at least you'll have one control that is controlling both fans. When you use something like Electro Industries, which I like and I've used, it's still sort of a little bit of a crapshoot setting it up and getting it balanced, and it's not going to really follow a truly variable speed fan. So recently on a project, talking to Wolf, one of the options they'll give you is a remote fan. And a remote fan's great because it's quieter, right? And so they'll give you a remote fan. And I said, great, will you sell us the same fan that we can use in a makeup air system? Because I'm just going to hook it up to the Electro Industries heater, but not use their fan. And can we just then wire them both in parallel to the same control? No. Why not? Well, because. And, you know, around and around and around and around. And, you know, anyone who's done passive houses have been around and around with manufacturers about all kinds of things. And so to me, that's a big market, is just someone who wants to make a high-end appliance that appeals to a person who's going to buy a kitchen that costs more than my house, right? And so they don't care what that system costs. It's not part of the discussion what it costs, but having it really work. And I think particularly with remote fans, you get a much quieter system, which means they might use it, you know, and that's a key thing. And then the final thing I'll say is these 600 CFM range hoods aren't 600 CFM. It's really rare. So when you see the Bosch 600 with a 6-inch outlet from the range hood, I mean, come on, that can't be 600 CFM. And we had a client who wanted 1200 CFM. And the problem is when you ask me or my colleagues how to really do that, we're going to give it to you if that's what you really want. And I said to him, why do you want that? And he said, well, my apartment in New York City has a 1200 CFM range hood, and that's what I'm used to. I said, can I send someone there to measure the CFM out of your range hood? And he's kind of geeky, and he's rich, so he said, sure, that'd be fun. So I sent another small Jewish geek to without much hair, younger, to measure it, and his 1200 CFM range hood in place was 370. So I said, so can't we just use a 400 CFM range hood in your new house? No, I need 1200 CFM. I just work here, you know?
Great. Thanks a lot, Mark. Okay, so I think we've just got 4 minutes left. I don't want to, you know, take people's extra time. So let's try and wrap it up. But we've got Frank, and then, I don't know, Jacob, if you took yourself off. Okay.
Nick installed it's a Bosch kitchen fan that retracts down to the counter level. And it's a wonderful system. We've had it serviced a couple times, but it's not maybe as effective as a big overhead kitchen fan, but it doesn't block the view when you're not using it. And it's worked very well. And, you know, Nick's people did a great job installing it, and it's been very successful. And we've never had a situation when we've used that and the fireplace at the same time. So I don't think it's ever been an issue.
Yeah, Mark designed that system. I think it would be a great follow-up session, Mark, if you're interested, just to go through what are some of these variables. So like if people have other ideas, it'll be great to hear ideas on sessions you'd like to see. And, but yeah, I would like to, that was an interesting system. Mark designed that, and the ventilation on that was fairly complicated. It looks simple.
Yes.
It's fairly complicated.
And then it was commissioned, right? So everything in that house was measured and commissioned, which is something, the more complicated the system, the more you have to pay attention to it, right?
Yes.
And so that's a piece of it too.
Yeah. Okay, Sarah, and then we'll wrap up.
Sorry, I just had a quick one because we've done a couple where we used like an electric one that's hooked up to the amperage of the kitchen fan that opens.
yeah.
But I was wondering about the barometric ones, if you can set it so it responds to negative pressure in the house and then opens accordingly. There are barometric switches for those makeup air, the mechanically closed ones, and we haven't used one yet, but we're very curious about avoiding the whole wiring it to the amperage on the fan. If anybody,
I think you'd need something that's going to give you a 0 to 10 volt. You can't. Almost all those systems have a pressure switch, which is proving airflow, so the heater doesn't come on without airflow. That's almost always a safety that's on those things. But then they're just an on-off. So you have to have one that would really give you a variable output signal that the fan could use as control.
So are you talking about with a preheater on it, or just in general that it?
Well, I'm just saying that where you see those now, those pressure switches are safety, and they're proving flow. They're in the circuit to a heater. And
okay.
you could sense pressure in the building and vary the fan, but I'm not aware of anything residential that would be like that.
Okay. Yeah, I mean, it's just like these mechanically closed ones. They're, it was totally like a rig-in, as we say in Quebec, a total like just making it up as we go along system. But it seems to work, but it's not measured, as you say. So yeah. Okay, great. Thanks.
Well, thanks, everybody. I feel like we answered all the questions, right? Maybe you left with more questions than you started with, but it was great to hear some folks' experience and what some of the issues are that are coming up, and sharing, what you have found that works. So thanks for being part of our initial building science discussion series, and the next one is going to be April 21st, which is a Wednesday at 5 p.m. And Nick's going to facilitate conversation. Then Mike Duclos is going to join us to talk about indoor air quality, different kinds of sensors, what are we measuring, how are we measuring it, what's working. So hope you can come back and join us for that.
Hey, Kate?
Yep.
There's also, in April, there's that upcoming FIAS Mechanical Summit, which is a multi-day sort of end of day thing, which looks really interesting.
Great.
It's actually on the 21st.
Oh no, same day. Okay. Good to know. Well, thanks everybody for coming. And Nick, did you want to chime in?
Oh yeah, that indoor air quality, that'll be an ongoing series because we're not even going to scratch the surface in the first one. So it's just sort of opening up for a building science discussion about what are we measuring? Why are we measuring it? What are we using? So it's not a one-time thing. We're sort of just getting into this. And so, it'll be a series, and we're open if people have ideas about topics they'd like to see, or sensors or things they're using that they're interested in. Just you can email them to Aaron or Kate or I, and we're trying to put together some new content for what are people using and how is it working?
Great. Well, thanks everybody. Have a great evening, and hope to see you again.